Imagine touching a glass surface and leaving behind a tiny trace. A fingerprint, invisible to the naked eye, yet carrying your personal signature, one that no other human being on Earth can replicate. A fingerprint may seem simple, just a set of curved lines at the tips of our fingers, but behind it lies a biological secret that has puzzled scientists for centuries. Why can no two people have the same fingerprint? More than 100 years ago, scientists realized that fingerprints are not random patterns, but rather an incredibly precise system designed to make every human being unique. But what's the scientific reason behind this uniqueness? And why don't even identical twins who share the exact same DNA have identical fingerprints? Let's start at the beginning. When a fetus is developing in the womb, specifically between the 6th and 13th week of pregnancy, the skin layers begin to form. At that stage, the fingerprints start taking shape at the fingertips as a result of a complex interaction between genetic factors and the environment inside the womb. Genes provide the general blueprint for the shape of the hand and fingers, but they don't define the fine details of the fingerprint. Those tiny details, the small ridges, bifurcations, loops, and arches, are influenced by unpredictable factors such as the pressure of the amniotic fluid, the position of the fetus, temperature variations, and even tiny vibrations from the heartbeat nearby at that moment. In other words, a fingerprint isn't purely genetic. It's the product of microscopic environmental conditions that occur once in a lifetime, making its exact repetition impossible. But could it ever happen, even theoretically, that two identical fingerprints appear somewhere in the universe? In biometric statistics, this probability has been studied in depth. Scientists estimate that the chance of two fingerprints being exactly the same is about 1 in 64 billion, and some estimates push that number to astronomical levels, far beyond the total number of humans who have ever lived. In short, from a scientific standpoint, perfect fingerprint duplication is practically impossible. But why did scientists choose fingerprints as the main tool for identification? The answer is simple and fascinating. Fingerprints never change throughout a person's life. From the moment they form in the womb until long after death, your fingerprint remains the same, unless the skin is deeply damaged. Even if the outer layer of skin is injured or removed, it grows back with the exact same pattern because that original design is embedded in the deeper layers of the skin. That's why fingerprints have been used in criminal investigations for more than a century. They are reliable, unique, and permanent. Now let's pause for a moment and ask, if fingerprints are unique, does the same apply to other parts of the body? The answer is, to some extent, yes. The human eye, for instance, has an iris pattern that's unique to each person, as do the veins beneath the skin, the human voice, and even the arrangement of teeth. But while all these features differ from person to person, fingerprints remain the most stable and the easiest to detect, making them the ultimate signature of identity. Identical twins present the most curious case. They share 100% of their DNA, yet their fingerprints differ completely. The reason is that fingerprint formation depends on tiny random variations inside the womb. A small change in hand position or a slight difference in the pressure on the finger can completely alter the ridge patterns. Even if the genetic code is the same, the outcome is different, much like drawing the same shape multiple times, but never producing an exact copy in every detail. Some studies have tried to understand this phenomenon more deeply. One modern theory suggests that a fingerprint is the result of organized chaos, a system that emerges from complex interactions between cell growth, skin tension, and micropressure variations during development. This system is so sensitive that even the tiniest fluctuation in timing or movement can create an entirely new pattern. It's similar to the butterfly effect in chaos theory, where the flap of a butterfly's wings in one place could alter the course of a storm elsewhere. A fingerprint is born from that same kind of delicate chaos, a moment where countless tiny interactions merge to create a one-of-a-kind pattern. But with all this complexity, What's the biological purpose of fingerprints? From a functional standpoint, we don't know with absolute certainty, but there are intriguing hypotheses. Some researchers believe that the ridges on our fingertips help increase friction with surfaces, improving our grip, especially in humid or slippery conditions. Others suggest that the ridges enhance tactile sensitivity, allowing us to detect textures and vibrations more effectively. So fingerprints aren't just a mark of identity, they serve a practical, biological purpose. In the end, we can say that a fingerprint is a record of a single moment in life, a moment that will never happen again because every condition that created it was completely unique. Perhaps that's what makes it more than just lines on the skin. It's a symbol of individuality in a world of billions. And every time you place your finger on a glass surface or a fingerprint sensor, remember, what you're leaving behind isn't just a physical trace. It's a timeless signature, unlike any other that has ever existed since the dawn of humanity.